What if it rained food? What if Earth was a cube? What if we had 9 lives? What if bits could fly? It's absurd. If money grew on trees, if we didn't have knees, if we walked through life slightly magnetical, it's absurd. Absurd Hypotheticals.
Hello everybody and welcome to Absurd Hypotheticals, the show where we overthink dumb questions so you don't have to. I'm your host Marcus Lehner, and I'm joined here today by Chris Yee and Ben Storms. Say hi, guys.
Hey, I'm Chris.
Hey, I'm Ben.
And the other day I was a little tired, so I was lying down in my bed, and I happened to find something interesting in my bed.
Oh.
Mysterious, I know.
Hold on, let me put you on mute real quick. Put a little clap right here. Now I can edit this bit out.
So I found a ruler in my bed, like a plastic ruler.
Okay, there's any number of jokes we can make here.
Yeah. Can we stop and make some jokes before we continue?
Go ahead.
All right. What was his name? Was it Kim Jong-un? Was he the ruler that you found in your bed?
Right.
That's not the joke I expected.
Was it the Queen, Her Majesty?
I think it's a very obvious measurement in bed joke that we could make here that I'll just sort of leave there for the listener to fill in the blanks on.
Okay. So yeah, I don't know, it was like a plastic, it had some thickness to it. It was a plastic ruler with rigidness. So I don't know how it got, well, I do know how it got there actually. So I moved into my, I don't know how I didn't notice it until now.
I'm building the mystery, but also I know who the murderer is.
Please don't say thickness or rigidity or...
So when I moved into this apartment, I had bought a new air conditioner. And I guess that came with its own ruler to measure out, because you need to cut this foam thing, insulator thing, to put into the window.
Okay.
So they provide a ruler for that. And we set up my bed right next to the window. So I guess we left the ruler on the bed before it had any sheets on it.
Oh, it was under your sheets.
Yeah, it was under the sheets. So I found it inside my bed.
That's amazing.
And I guess we just put the sheets over it. I have two sets, because I bought a new set of sheets too.
Mm-hmm.
And the set came with
a ruler.
This is the second ruler I found.
No. So it came with an elastic sheet where it has elastic around the end, and then it came out with another one that doesn't have elastic. It's just a flat sheet.
Yeah, you got your top sheet and you're fitted. Yeah, you know.
Yeah. And when I wash my sheets, I usually just wash the top one. I don't wash the elastic one. So I've never really taken that elastic one off.
Wait, hold on. We got to back up for a second.
Wait, do you sleep on top of the top sheet, or do you sleep underneath the top sheet?
I sleep on top of it.
Wait. Hold on. We got to back further up now. So you're telling me... So you put on the fitted sheet, and then put the top sheet over that, and you just pull a blanket over yourself and lay on top of the top sheet?
Yes.
Huh.
It's not how those sheets work.
No.
I was not aware that this is unusual.
It is. We found a nested intro topic.
I mean, I guess that's the cause of why the ruler got stuck in there in the first place.
Right.
I will say, I don't use the top sheet. I abandoned the top sheet. I don't like the top sheet. But I sleep on the fucking fitted sheet. I stay on top of the fitted sheet.
I mean, I'm a top sheet guy, but
Well, I mean, what's the difference? It's the same thing. You're sleeping on top of a sheet.
Well, but having the sheet over you, I don't know. It's just...
Well, what's the difference between me and Marcus?
Well, one, you're wrong and insane, and two, I'm at least know what the top sheet's for and have elected not to use it.
I have an extra layer of protection over my mattress, though.
What are you doing that you need that much protection on your mattress?
Do you have a mattress cover?
I don't.
I don't either, to be fair.
Well, that's what you're supposed to. That's the first. You're supposed to first put the mattress cover down.
I'm hearing that we all have different bed setups, and we all think each other is weird.
Well, yours is the weirdest.
I guess.
I think Ben minus the mattress cover is the most correct.
Probably.
Yeah, I have the traditional mattress strategy.
Thing is, when I'm at a hotel and they have both the sheets, I never sleep under. I hate sleeping under the top sheet.
Well, the hotel top sheets are also you have to rip them out from underneath the bed. It's you need some force. You need to put effort into getting that top sheet up.
See, actually, speaking of hotels, in a hotel, I will always sleep under the top sheet because
they don't really wash the...
Yeah, you're guaranteed they wash the sheets, but not they wash the blanket.
That is true. I've heard that before. I don't care. I don't like sleeping under the top sheet.
This is buck wild to me, but
The thing is, I moved in July, and I didn't find the ruler until like a couple days ago. So it's been in my bed for like 4 months.
This is symbolic of each of our relationship status. Like, Ben, you're now married.
Yes.
So you've got your bed shit together.
Yep.
You have all the proper things in the right
we change our
places.
sheets every 3 or 4 days.
That's a lot.
It
That's
is.
a lot.
I agree, but
That's a lot of sheet changing.
I agree. Maybe it's like a week.
Okay.
She
So
usually
you're
does it,
way
so-
ahead of the curve.
Yeah.
I'm somewhere in the middle. So I'm in a long-term relationship. Me and my girlfriend are living together now for like 3 years. So we've elected not to use the top sheet, but we use the bed properly for all intents and purposes. And Chris, you're single, so you
So I have
are
a ruler
a crazy
in my bed.
madman and has a fucking ruler like that's been in his bed for months.
I sleep diagonally. It's great.
Oh, I do miss the diagonal sleep.
I am jealous of that, but we do have to move on. We have a lot of shit to get through today, guys, because we have quite the hypothetical today. It's special for Thanksgiving, and that is, what if Earth was made of Thanksgiving dinner? Ben, you're gonna be first. I'm gonna let you explain what this means.
Yeah, so we kind of definitely wanted to like lock down exactly what we're saying with this. I guess first off, most importantly, we're gonna ignore the fact this food's gonna spoil because that's gross. And also the Earth would explode.
Do you want to provide any?
I should
No
probably
explanation.
no. Yeah, you got it. No. Basically, when food is decomposing, it produces methane, and we actually in a prior episode, all the way back in episode 5, we found out that at a certain point, if there's enough methane like concentrated in the atmosphere becomes flammable, and when the entire atmosphere is flammable, eventually it's going to explode. It's a pretty safe bet. So we're gonna ignore that.
For the first time, we're going to ignore that the world explodes instead of ending our podcast on it.
Yeah, it's real growth for us.
We've definitely covered it plenty of times, so
Yeah.
just listen to our old episodes.
Other things are going to happen. There's not really going to be any plants because you can't grow food in food or plants in food. I don't think. I mean, I guess there'll be like.
Can you not?
I
I was curious. I was gonna look at that a little bit, but I didn't dive into the nutrition that plants need.
I looked at it a little bit, and you don't necessarily need soil, but you need like specific types of nutrients, and I don't think you can get it from food.
Right. Yeah. There'll be like. I guess there could be. I guess we don't want there to be mold because that would also get into a similar problem. I don't know.
There's a list of stuff that you could use that was like organic, and most of it was just like poop, like
Right.
different types of poop. So
Yeah. Well, regardless, there's probably not going to be plants, but we're also going to kind of ignore. We're going to do a lot of hand waving this episode because the lack of. If we didn't hand wave, the question's going to get pretty boring. So
I mean, plus we're building like this, cloudy with a chance of meatballs world. There's gonna be hand waving.
exactly.
Yeah.
And then finally, even though the entire world is made out of food, we're not going to talk about the like effects on your body from eating exclusively Thanksgiving food because we already did that back in episode 26. Last year, last Thanksgiving.
we've done a lot of stuff on this show.
We went from all meals being Thanksgiving to all Earth being Thanksgiving. So apparently, come back next year when we talk about the entire universe being Thanksgiving.
When you talk about the people being Thanksgiving.
Right? Yeah. So what I looked at, I was originally going to look at just sort of the general like, if this happened overnight, what would happen to the world. And then the first thing I looked at was mashed potato mountains, and I went real deep on mashed potato mountains, guys. So that's kind of what I'm talking about here. There's not really any real reason for mountains to be made out of mashed potatoes aside from it looks really funny in my head.
Yeah, it's the first thing that pops into my mind when I think about it.
It is, right? I don't know why. It doesn't really make sense, but
Well, as a kid, you always make the mountain out of mashed potatoes. Like you play with the mashed potatoes and you make a mountain.
yeah, I
because
guess so. Yeah,
the easiest shape to make when you're like 8.
right. It makes sense. But so I went into mashed potato mountains. I guess the first question I want to figure out exactly, how much mashed potatoes? How do you refer to how much mashed potatoes?
Much. I think it's much.
That feels weird as hell. How much mashed potatoes this would be?
It's like how much water.
Yeah, I guess. Yeah. It's just weird because it's a plural. All right, anyway. So it's surprisingly hard to find the volume of a mountain. I really tried to find just like, I guess it makes sense that no one's like actually, it's really, mountains are irregularly shaped. So it's pretty hard to like get an actual measurement of them in that way. So I understand why it's not out there, but I had to kind of improvise. So I decided to approximate with a cone. But it also turns out that most mountains aren't actually cone shaped. Like everyone sort of in their mind sees a mountain as like, sort of like the pyramid, but I guess, a cone going up. There was actually a study in this journal, Nature Climate Change in 2015 called Global Mountain Topography and the Fate of Montane Species Under Climate Change, which was basically the idea of the study was that a lot of species live on mountains are sort of migrating up the mountains as the plants gain hotter because they're trying to stay at the same temperature. And there was this concern that like they were going to run out of space and have a higher extinction rate or extinction risk. But it turns out they looked at this like big data set of like 182 mountain ranges around the world, and only like 32% of the mountains actually had a just regular decrease in area as the elevation increased. There were a lot that sort of like bubbled out and stuff too, which is really interesting. I had no idea that was the case. And it's actually kind of cool because it turns out that like some of these animals will have more available land, which is a whole other bucket of problems, but good for them. But anyway, big point is most mountains aren't actually cones, but I did find one that was definitely a cone. It is Mount Damavand, whatever, in Iran. It's the highest peak in Iran. The peak is about 5,670 meters above sea level. It is a dormant volcano. And it makes sense. A lot of the mountains that were like conical were volcanoes because of how they form, So I looked at a topographic map because it was really hard to find. Even though I had the peak, I had to figure out where it stopped, like,
Sorry, I thought you said you had to pee.
Oh.
I was trying to...
How does that relate?
I was trying to read this topographic map. It was really hard.
Really had to pee. Couldn't focus. Yeah, so I had the peak. But I had to figure out what, like, the base was. And I couldn't really find, like, a good number on that somehow. So I just looked at a topographic map and figured out where it kind of leveled out, like, evenly around. And that was about 3,400 meters up. Was kind of where it stopped being, like, a real cone. So this isn't really the full mountain, but it's most of it, at least. And you wind up with a cone that is roughly a 4,000 meter radius and a height of 2,270 meters, which gives you a volume of 38 billion cubic meters.
That's high. That's a lot.
It's pretty big. Yeah. It's a big old mountain. And then there's this wonderful website I found called aquacalc.com, which gave me the density of homemade mashed potatoes.
I went to that website a lot this question.
It's a good website.
What is this website? Aquacalc?
Aqua-calc.com.
It's the first thing that comes up if you search the density of anything.
Yeah, it's pretty awesome, actually. So the density of mashed potatoes is about 0.89 grams per cubic centimeter, which means that we have roughly 74.3 quadrillion pounds of mashed potatoes in this mountain top here.
Damn, that's a lot of potatoes.
It is. It is, actually. It's actually more than I expected, which, I mean, it's a mountain, so it makes sense. But I also found out, so they also have, I looked up the calories in mashed potatoes, and it works out to roughly 400 calories per pound of mashed potatoes, which is actually less than I expected, but does give us roughly 3 quintillion calories in this mountain.
It's always fun when you pass billion.
It is. I had to do a lot of that thing where you like type out all the zeros and then go through them by 3 to make sure you have the right number.
Yeah.
Yeah, zeros, thousands, millions, billions, trillions. Okay, we're in quintillions,
Yep.
I think. Hold on, let me check again.
I had to check so many times. It was really bad. But with this 3 quintillion calorie mountain of mashed potatoes, there are roughly 7.7 billion people in the world. And if we wanted to give them 2,000 calories a day each, which is, that's, good goal right there. We could feed the entire planet for 533,000 years.
Holy shit.
Yeah.
All right, let's get on this mashed potato mountain train.
So we've solved world hunger. We haven't solved world nutrition because it's all mashed potatoes, but because also, once again, that was part of one mountain. Yeah. So we have a lot of mashed potatoes. And yeah, that number, that time frame is actually less because I'd imagine there would be a population boom because there's so much excess food now, assuming that everyone didn't just die from eating exclusively mashed potatoes. But point is, food is no longer really a problem. So we've solved world hunger, but the more important question we have to ask is, if you stand on a mashed potato mountain, do you sink into it? Because I need to know this. And the first question you have to ask here is, are mashed potatoes a liquid or a solid? Which is a surprisingly tricky question, because they will fill the container that they're in, which is kind of, the main, qualification for being a liquid generally. But they're definitely, if you like hold some up, they're not going to drip. So what are they? And this is actually a question that the TSA ran into back in 2008. There was a situation at security check at Chicago O'Hare Airport in 2008 where someone had brought a container of mashed potatoes, and the TSA said they had to take them because they were a liquid and it was more than 3.4 ounces. And eventually, of course, the TSA won and they stole their mashed potatoes.
and ate it for lunch.
I have to imagine they did, right?
Yeah.
Like, what do? You have to eat the mashed potatoes, yeah? Like, there's no question.
Otherwise, it's a waste of food otherwise.
Right, it just seems wrong.
I mean, it's like how they drink all the liquids that they confiscate. You can't just throw out that bottled water.
Oh, yeah. I really hope that the person who was doing it, like, asked them straight up if they thought the mashed potatoes were a security threat, and the TSA agent had to, like, confront that question.
Did they not give the guy the option to eat the mashed potatoes before going through?
I mean, they probably did, but so imagine you had like a quart container of mashed potatoes. Would you just, if you have a flight in half an hour, would you just house a quart of mashed potatoes while standing in line, just like maintain eye contact with a TSA agent? Because now that I said it, I probably would.
Yeah, I've seen crazier things at the airport. Like even normal things. Like I took a flight at, I think it was a 9:00 flight, so I was at the airport like 8:15 a.m.
Mm-hmm.
And the Popeyes had a line like out the fucking door. I'm like, who is
They do have breakfast sandwiches, I think. They have like chicken on a biscuit that you can get. I think it might be like specifically an airport thing, but I have seen that.
Is that what it is? Because I was so confused. I'm like, my body's barely ready for like this like fruit smoothie I'm getting over here. But how could I even stomach like fried chicken and fries right now? I would die.
I mean, chicken and waffles is a thing. They probably have a chicken and waffles thing.
Right? They might actually. I'm not sure.
8 in the morning's a little early for chicken and waffles.
No time is too early for chicken and waffles. Anyway, yeah. So technically, I looked into it. Mashed potatoes are actually a gel, which is technically a solid, but gels are weird. They're actually mostly liquid by weight, but they behave like a solid when they're at a steady state, and then can take on liquid characteristics when they're disturbed. So like hair gel is like this, where, you know, if you tip over a thing of hair gel, it's not going to pour out, but you can like obviously peel off some, you know. Technically a soft contact lens is actually a gel. It's there's like a certain kind where they like evaporate the water out and it takes on a more solid state.
I don't like the idea that contact lenses fall in the same category as mashed potatoes.
Well, yeah, that's kind of a little unsettling, but you know, whatever. But yeah, gels basically it is mostly liquid, but there is a like 3-dimensional cross-linked like lattice network of solids within it that hold it together. So in this case, the potato is the solid, obviously, and the milk/butter/various greases are the liquid. It's not really have any fancy math actually on whether or not you could stand on the mountain and not sink into it, but it is in a steady state at that point, so it is still a solid, and at that point it's pretty much just a can it hold your weight question. And I think it's pretty safe to say that the, you know, multiple quadrillion pounds of mashed potatoes can hold your tiny, tiny weight. So you should be
That's not how weight
okay.
works, but sure.
You know what? You're not how weight works. It logically makes sense. It's a solid. The end. Not actually the end of the answer, though, because the one thing that I did go into as well is that if the mountains are mashed potatoes, then obviously mountain springs are gravy, and the snow caps on mountains would be frozen gravy, which I did look into. You can freeze gravy as long as it's flour-based. If it's cream or milk-based, it'll separate when you thaw it, and that's disgusting, and I don't want to think about it, so ours is flour-based.
Well, now I have to change my answer. It was based on gravy being milk-based.
Uh-oh. But the gravy caps do bring about one final issue, which is avalanches. So avalanches happen generally because there's like a slab of snow that gets too heavy and sort of just fractures off the snow that it's, you know, with, and sort of slides down a slope. And this is still obviously going to happen with our gravy snow. And I think it would actually happen more because there's oil in the gravy and the potatoes. So I think there would be just, you know, it would be more likely to happen. And obviously, as an avalanche is sliding, it picks up more snow and gets larger, and that's how you get into, you know, real dangerous situations with them. But then, as I mentioned, our mashed potatoes are a gel, and when they're disturbed, they can take on liquid properties. So not only are you going to keep picking up more gravy in this avalanche, you're also going to start sort of stripping off the mashed potatoes into the avalanche as well. So you're going to wind up with these basically just huge sliding walls of mashed potatoes and gravy, which will be delicious, but also highly, highly dangerous. And slab avalanches, as are, they move at like 80 miles per hour, and they're capable of destroying like forests and small villages if they get big enough. So you kind of wind up in this fun situation where mountains are both a near infinite food source and also an impossibly dangerous death trap. So I don't really know exactly how that works, because people probably want to live, I guess you don't have to live near them because everything is food, but if you want potatoes, you got to live kind of near them. But I guess you don't want to be too close because...
You want to be like exactly one town away.
Right, exactly, yeah. You don't want to live right near them.
I mean, they'll probably be mining it or something. There'll be like a potato mine or something.
I guess you just wait. Actually, you probably wait for the avalanche to come down to you and then eat from the avalanche. Like once it comes to rest.
Yeah.
There you go. That's what you do. Because it's pre-mixed too, you know? You got the gravy all throughout. That's awesome.
But also, is there going to be a time where, you know, the avalanche hasn't happened for a while, and then you're just like looking at the mountain like a few miles away, you're like, man, I want to go up. That's right there, those mashed potatoes, but it could collapse at any time.
Right. It's a real dangerous situation. But these are the risks you have to run in order to get your mashed potatoes in this. I can't tell if it's a paradise or a hellscape, but regardless, this is what I looked into this week, was literal amounts of mashed potatoes. Chris, what'd you do?
So I went a little more big scale with my answer. I looked at the layers of the earth, and basically just like, what would the layers of the earth be if everything was Thanksgiving dinner? So starting with the crust, I'm going to go outside, work my way in. So the crust of the earth is only 1% of the volume of earth. So it seems big, but it's not really that big.
I mean, it is big, just,
It is big, but in relation
relative,
to the rest of the earth, yeah. So the crust is broken up into like two categories. There's the oceanic crust and the continental crust. The oceanic crust is like denser rock. It's more like basalts, diabase, I guess. I don't know what that is. And gabbro. I don't know if I'm pronouncing those right. I've never heard of those rocks before, but apparently they're denser rocks. And then continental crust is made of less dense rock like granite and stuff. But instead of that, for our Thanksgiving dinner earth, I decided to make our crust pie crust, because obviously, like,
right, yeah,
no other choice.
That makes sense.
Yeah. So that's the crust. Below the crust is the mantle. So the mantle is made of like various silicate rocks. It's like a category of rock. And the mantle is 84% of Earth's volume. So way, way bigger, or way, way more than the crust. And on a geological timescale, the mantle actually acts as like a viscous fluid. So it's like moving around and circulating and stuff.
Oh, wow.
And we'll get more into that later. But we had the pie crust for our crust. So I figured like the natural progression from that would be pie filling for the mantle. So I looked up like the most popular types of Thanksgiving pies. And in 2016, I couldn't find a more recent one than that for some reason. But in 2016, pumpkin pie was the most popular type of pie for Thanksgiving in the US.
I feel like, okay, slight digression. Is pumpkin pie super overrated to anyone else or just me?
Oh, no, it's so overrated.
It's a little overrated. I still like pumpkin pie, but I do think it's overrated.
Like, it's in my lower tier of pies. I don't know.
It's fine, but like, you get a good apple pie,
right?
Or like
any kind of berry pie.
Yeah.
Kind of funny that you say that, because like the site that I got this information from, they like broke it up by state. And in the Northeast, apple pie was the most popular, and then like the rest of the state was pumpkin pie, or the rest of the country was pumpkin pie.
Yeah, it checks out.
Yeah, so we have a pie crust for crust, we have pumpkin pie filling for the mantle, and now I'm going to get into sort of, I had to get through those to get to what I kind of wanted to cover in the first place, which was tectonic plates. So tectonic plates are part of like the lithosphere, which is, it's made up of the crust and the upper part of the mantle, and it acts as like a rigid thing. It's rigid.
Like your ruler. Your bed ruler.
Yeah. And below the lithosphere is the asthenosphere, and that's basically just the lower mantle, and that's the viscous part of the mantle. And what happens is the crust, because the crust is less dense than the mantle, it basically like floats on top of the mantle. It's a property called isostasy.
Or floating.
Or floating, yes.
Also known as shit floats.
Well, isostasy, I think, is specifically the crust on the mantle.
Ah, fair enough.
So I figured that our pie and our pumpkin, our pie crust and our pumpkin pie filling should kind of follow that same rule with the density. So I looked up the densities on aquacalc.com or whatever it's called. And the density of pie crust is 0.55 grams per cubic centimeter. And the density of pumpkin pie filling is 1.14 grams per cubic centimeter. So we're good. The crust is less dense than the filling. It follows the rules of physics.
Checkmate.
Nice blend in this specific way.
So far, our Thanksgiving Earth could work. So what forms the plates is basically the lithosphere. It like breaks up into pieces as like heat tries to escape and like the parts move around and stuff. It breaks up. And on Earth right now, there are 7 large plates, and then there are like a bunch of smaller plates that are less significant, but they're still there. And the average movement per year on Earth right now ranges from 0 to 100 millimeters per year. So it's very small movements. You don't really notice it that much. And at the boundaries of these plates, or they call them faults, this is where like earthquakes happen, volcanoes form, and like mountains form. So like if you have a convergent fault, meaning that 2 plates are moving towards each other, then one will tend to like sink below the other, and it'll like go into the mantle and become part of the mantle. And then on the other side of the plate, where it's moving away from the other plate, the divergent fault, new crust is forming from the mantle. So the parts of the mantle are coming up and it's forming new crust. And then there are faults called transform faults where they're moving parallel to each other, and no crust is being created or destroyed in that case. So as I said, at these faults, that's where earthquakes are being formed. An earthquake is basically just like energy is being built up from like the 2 plates like pushing into each other, or like it's just building up energy, and then there's like a sudden release of that energy, and that's what we feel with the earthquake. And with the pie crust, I figure the pie crust is going to be way more crumbly. It's not going to be as rigid, so it requires a lot less energy to break down. So you're not going to build up that energy, and you're still probably going to have earthquakes, but they're going to be way weaker, and they might actually happen more frequently just because there's a release of energy more frequently. It's just a lower amount of energy.
Right.
So in terms of the mantle, I was calling the mantle viscous before, but that's over a geological timescale. So that means like over millions and millions of years. Over the short term, it acts more as a solid.
Like our good friend, the mashed potatoes.
And pie filling is actually like way more viscous than our mantle now, obviously. So there's going to be way more flow in the pie filling mantle. And I think that's going to result in the plates, they're going to be moving way more often. Like it's going to be way more than just 100 millimeters per year. I don't have a number, but
yeah, because everything's squishier and more fluid. Yeah. Now we got instead of being made out of
everything's more fluid.
Instead of being made out of rocks, our Earth is made out of food goo.
Right.
Pie.
Yeah, pie's a better word than food goo.
So all these like geological features are going to form way more quickly, and they're going to happen more often, just because like the pie crust is also more crumbly. So I don't think the large tectonic plates are going to be there anymore. I think it's going to break up into a lot of more like smaller plates, and at the boundaries, there's going to be like way more boundaries. So there's going to be way more earthquakes and volcanoes and mountains forming on a smaller scale, but like everywhere.
That sounds fun. So we're leaning more towards hellscape then, is what we're saying. That's kind of what we're coming down on? Okay,
yeah,
cool.
Kind of. So next I looked at what happens when pie filling is heated, because the mantle is a very high temperature. And what happens when you heat sugar, because pie filling is a lot of sugar, and I actually looked it up, and 100 grams of the pie filling that I was using was 50 grams of sugar, so it's half.
This is why you never look at things being baked, because it's just like, oh, hey, here's 5 pounds of sugar and 8 sticks of butter, and
right.
I'm just going to mix them until it's a pie, and you're like, is that really what I'm eating?
Yeah, but if you heat sugar, what happens is that it starts to caramelize. So what's going to happen with our mantle is basically the whole thing's going to turn into caramel.
So it's a delicious hellscape.
Yes. It's going to be a pumpkin spice caramel hellscape.
So Starbucks.
Yeah.
Caramel hellscape. I love it.
So that was the crust and that was the mantle. Now to the core. We're working our way in.
Tasty core.
Actually, I said we're working our way in, but I'm gonna skip to the inner. So there's the inner core and the outer core. I'm gonna skip to the inner core. So the inner core is only 0.7% of the Earth's volume. It's very small compared to the rest of it, even smaller than the crust. And we don't really know that much about it just because it's really deep.
It's hard to get to.
Yeah, but we believe that it's made of solid nickel and iron, or like a nickel and iron alloy. That's what we believe it to be. And per Marcus's request when we were discussing this question, I decided to make it stuffing.
Well, yeah, it's gotta be stuffed with stuffing. That's got the Earth's gotta be made out of.
So we have a stuffing inner core, and then the outer core. Right now, it's made of a liquid version of the nickel and iron alloy, so it's fluid. And I really wanted to make it, because we haven't really included turkey yet, I wanted to make it a turkey and then the inner core would be stuffing. But that doesn't really make sense in our case, because it's supposed to be liquid, and I don't know that would just be weird having a layer be a turkey.
I can mentally picture the core of our Earth being just a giant turkey full of stuffing.
As good as that image is, we need it to be liquid, so I decided to make it gravy. But the problem with gravy, it's not dense enough. It doesn't follow the rule that like the inner part of the Earth is supposed to be denser than the outer part. So instead of gravy, I went with cranberry sauce.
Ooh, nice.
Cranberry sauce was like just dense enough to fit that rule. So cranberry sauce is 1.18 grams per cubic centimeter compared to the 1.14. So it works. And then the stuffing actually is less dense, but it's compressible. Like it's a solid that's very easily compressible. So it'll just get more dense, and it fits that rule. Now, how does the different core affect us? It doesn't really affect us that much, just because it's so isolated from us. It's like there's a giant layer of mantle separating us from the core.
We got all this good pie filling protecting us.
Yeah. Well, it's caramel now.
All right, caramel.
Even better.
Yeah.
But one thing I did look at was that, so right now our magnetic field is believed to be caused by the nickel and iron fluids in the outer core, because the outer core is a fluid and it's moving around. It's creating what's called eddy currents. So it's basically just creating a magnetic field from that. And I wanted to know if the same thing would happen with cranberry sauce.
Which I'm sure was just answered online by someone,
Right,
quick,
yeah, of
quick
course.
Yahoo answers.
Well, so what causes the eddy currents is like you need a conductor to be like flowing. So I looked at how much, like, does cranberry sauce have any conductors in it? It does have very, very, very trace amounts of conductors. They include like copper and iron and like other minerals, sodium, stuff like that. But it's like very little, like less than 1%. And some of the conductive material in it is more conductive than nickel and iron. So an example, it does have a little bit of copper in it, and copper is 6 times more conductive than iron. But again, the amount was so small that it doesn't make a difference. So I think the magnetic field is going to be negligible. We're basically not going to have a magnetic field. And if you listen to episode 54 of our podcast, we actually cover what Earth would be like without a magnetic field. So if you want to listen to that, that's like a continuation of this answer, I guess. Kind of.
I think we can spoil a little bit. What happens is the atmosphere gets stripped right away from the Earth and is no good for nobody.
Yep.
Yeah.
So really leaning into that hellscape vibe.
Yeah, the hellscape. So basically our final Earth is going to be lots of caramel volcanoes and fast-moving crust. I don't know how fast. I don't know if we can like feel it when we're moving. Probably. I feel like it's going to be moving pretty fast. And then we're not going to have an atmosphere because of magnetic field. So not that fun.
Not that fun. So Chris, you said you went big scale. I kind of also went even bigger scale.
Yeah.
So not the whole universe, but so when I was looking at the question of what if Earth was Thanksgiving dinner, what got me interested was if the Earth could even form from Thanksgiving dinner, rather than taking the different parts of the Earth and replacing them just, magically with those ingredients. I was looking to see, hey, let's say the ingredients for our solar system were Thanksgiving dinner. So strap in. There's a lot of science learn about to happen on this podcast. So I'm going to start by explaining how the solar system formed in the first place. So basically, what you start off with is the raw material from the Big Bang. We have is a bunch of gas, basically all hydrogen and helium, that slowly comes together under gravity until you form a kind of a disk, a solar nebula. And so basically, the way this disk is the star of the sun. And so you kind of have like this ball of gas, and then the ball has kind of a ring around it, like a big disk rotating around it. And so over time, all this matter kind of comes together and slowly compresses under gravity until it forms the sun. And while this is happening, the stuff all around the disk is what's actually going around to form the planets. So the way you get the nice clean universe is over time, your sun forms, all that helium and hydrogen in the sun starts to start nuclear fusion with hydrogen in the middle of the sun, and then the sun starts to emit what they call solar or stellar winds, which kind of push away all like the loose gas, and so anything that hasn't been formed in a planet yet kind of gets pushed away from the sun, and all the other planets that manage to form are still around. So going into it, kind of I want to see what would be different about this compared to how our universe formed. And the main thing is the elemental composition of the initial matter. So like I said, the universe starts off at 74% hydrogen. A solar system starts off as 74% hydrogen, 24% helium, and about 2% heavy metals like iron, nickel, and all that. I found some rough numbers for the elements that would be in a Thanksgiving dinner. And by rough numbers, I mean I found numbers for mammals as a whole and plants as a whole.
That's pretty rough, but those are the categories of dinner, so.
Yeah, so I'm like, well, it's going to be organic. It's effectively mammals and plants. So animals are about 62% oxygen, 21% carbon, 10% hydrogen, and then a couple other random things, little nitrogen, calcium, phosphorus, all like under, 3%. Plants are more carbon than oxygen. They're 54% carbon, 39% oxygen, 7% hydrogen, and literally like nothing else. Like the next highest thing on a plant is like 0.03% nitrogen. So the plants are made entirely out of carbon, hydrogen, oxygen. So overall, our kind of mass is, overall we have way less hydrogen. We have about 8% hydrogen by mass versus 74%. We have no helium and effectively no heavy metals at all. So before we get to the Earth, I'm actually going to start with the sun. So, like I mentioned, our sun runs on hydrogen fusion reactions. And this puts it in the category of, its ordinary star phase, where it has plenty of hydrogen fuel. When the hydrogen fuel runs out, it starts to turn into a red giant because the reactions change, so now it can't really contain itself in that small ball. So it starts to expand, and it gets much, much bigger. Actually, when our sun becomes a red giant about 5 billion years, the radius of the sun will be larger than the orbit of the Earth. So the Earth would actually be like absorbed by the sun as a red giant.
That's the way I want to go.
I want to live 5 billion years and get eaten by the sun.
Fuck yeah, I do.
And so at this point, basically what's happening is that the center of the sun now switches from hydrogen fusion to helium fusion because it's now fused all the two hydrogens. If you take two hydrogens fused together, you get a helium. So now it's got helium fuel in the middle, and it's kind of doing a little bit of still hydrogen fusion on the outsides, but now it's kind of in this big red giant phase. And then it's in here for actually, millions of years, but, less millions of years than the hydrogen phase. After the helium runs out, the sun starts to actually die and become what they call a planetary nebula, which funnily has absolutely nothing to do with planets. They call it a planetary nebula because the guy who discovered it was looking at it and was like, that kind of looks like a planet when you look at it through a telescope.
Yeah, that happens in science every once in a while.
Scientists, they're just like us. Sometimes stupid.
Yeah. So I was excited to get some planet-forming facts out of planetary nebulas. Turns out, no, there's no new planets forming in the planetary nebula. It just looks like a planet from far away. So at this point, the sun is kind of not exploded, but it's close to it's like half exploded, where it's kind of the sun that's unstable. It's now doing fusion with things like carbon and oxygen as opposed to hydrogen and helium, because now it's fused together so many elements that they're now bigger compounds. And because it's unstable, it starts to kind of emit off its outer layers into the area around it. So it kind of fills up the solar system with just gas and bits and hydrogen and helium and all those pretty colors you see on the Hubble pictures. So this is kind of its last stage of quote-unquote life, where it's still doing fusion. because once it fuses enough carbon and oxygen into nickel and iron is its last fusion stage. Once it's nickel and iron, it can't do fusion anymore. There's not enough energy for it, and it becomes what they call a white dwarf. White dwarfs are actually very small, but they're incredibly dense. So the white dwarf that our sun will become will actually be about the size of Earth, but it'll still be the same mass, more or less. So to put it another way, a matchbox made out of like white dwarf sun material would weigh as much as 15 elephants. So just like a bonkers dense form of matter. So what does our sun look like if we, instead of starting it off with good hydrogen and helium, if we fill it with our Thanksgiving dinner? So we have some hydrogen to start off. So we have 8% of our matter is hydrogen as opposed to the 74% that it was before. So we're fast tracking through burning up our hydrogen fuel, which means we're also fast tracking through our red giant phase. So we're going to be in planetary nebula pretty quick. And I think exasperating this is that the core materials during the planetary nebula phase are carbon and oxygen, which is what we're starting with mostly in the first place. That's most of our matter to start. So our sun's not going to be in great shape for very long. That's how I was looking at it. The other way that this could happen is it could also form into a brown dwarf star, which is basically a star. It's like you start off with all the matter and it comes together, but never gets enough energy to start doing fusion. So basically it's like a false start star that's just like a blob of matter that floats around. But I decided that one is boring. So that's another possible. That was just for scientific accuracy. That's another thing that could potentially happen. But if we get it, I think there's still enough fuel there to start the fusion. Fusion goes, but we kind of just skip ahead quickly into the sun dying. We kind of gave it like grade F fuel. So that's what our sun's doing. So let's go back. Let's talk about the Earth. So now we're going to talk about how planets actually form out of this disk of random elements and gas. So it's kind of a two-step process. The first step they call condensation, which is the process by which the first microscopic sections of the dust cloud slowly come together to form small little lumps. And kind of what's important about this is that when it's down at that microscopic scale, gravity is not really a player. It's only once they start coming together that, you can start having gravity be like a driving force. And so once you have those small lumps, now you're in what they call the accretion phase, which is when all these small lumps start bumping into each other. But since they have gravity, they'll bump into each other and stick together. And now you have a slightly bigger lump that'll bump into more stuff that'll go bigger and bigger and bigger and bigger and kind of scales up from there. So from the small lumps of like a few centimeters, you kind of hit this new phase where now you're just waiting for things to bump into each other to start making the cores of planets. One interesting thing that I didn't really realize until I was doing this research is, as I'm sure you guys are aware, there are two types of planets in our solar system. We have, our gas giants, and we have our terrestrial planets. With the, terrestrial planets being made of, like Earth, just being like made a big rock, and then the gas giants, which are all just, made of gas. But what I'd never noticed is that all the terrestrial planets are the ones close to the sun, and then once you hit Jupiter, they're all gas giants going out. And there's actually a reason for it, and it's that they have what they call the frost line in the solar nebula. And basically, inside the frost line, it is too hot for hydrogen-based compounds like water and things to condense, to form these little droplets and things that they would need to start coming together. And so the reason you don't have any gas giants close to the sun is because you can't actually get a planet going with hydrogen and helium as its base. The only thing that you can use, the only thing that can condense at, closer to the sun are the heavy metals. So even though iron makes up less than 2% of the original starting material, Earth is 80% iron, because iron is the only thing that can actually condense that close to the sun where the Earth orbits. And then Jupiter is almost entirely hydrogen helium because it's out past the frost line and it can pick up all those hydrogen helium things, and it has plenty of shit to collect, which is why it's so much bigger. Now, for us, our situation's a little different. So we don't have any heavy metals. So my first thing was oh shit, Earth doesn't form at all because it can't be that close to the sun. And so nothing will ever condense and it'll never become a planet. But because we're starting with a tray of, mashed potatoes and we're starting with like a cooked turkey floating around, we kind of skip the condensation phase a little bit. So as long as it's not so hot that the turkey and everything breaks down into its base elements, we have what we need to start doing the accretion and collecting matter. So I think the close planets like Mercury, Venus, stuff like that, it might be hot enough there where those are like vaporizing. It was really tough to find out what temperature like meat would break down into its base elements, because if you look up about anything that has to do with heat and meat, it tells you nice fun cooking facts.
Right.
Yeah, it's like, how do you cook it properly? Don't cook it too hot.
Yeah, it's like, oh, at this point the parts that make up the meat start breaking down, and that's going to be tough. And I'm like, no, I want to know when it vaporizes. I want to know.
We didn't mention this before, but I was originally going to do this answer, and I ran into that problem. I was like, I don't think I'm going to do this anymore. And then you picked it up.
I picked it up because I found out about the frost line. I was like very excited about it.
Yeah.
So really, we have from the start, we can skip this whole, and the condensation phase takes a long time. Because you're really going from like microscopic gases orbiting the sun that happen to like connect a little bit and then happen to bump into like another tiny thing. And it's like exponential growth, because once you have big things, they're much better at attracting other things. So it'll work out nicely because our sun's going to, burn out much quicker, but we're going to get our planets in there faster as well. But kind of big picture, based on our element composition, there would be no Earth. But because we start off with lumps of food, we could still have Earth. And it doesn't necessarily have to be a rocky planet. Earth could end up a gas giant, just because once you have the core going, it's then strong enough to pick up all those different, for all those gases. So all the stuff closer to the sun that kind of vaporizes into gases, they'll get pushed along, and Earth will be like the first big thing that can capture it. So if the solar system was made out of Thanksgiving dinner, Earth would probably be a gas giant.
Just like me after Thanksgiving dinner. Hey.
Payoff.
It was funny. I actually ran into the same thing you did, Chris, with the magnetic field. So I agree. There would be no magnetic field, which would be kind of tricky, where the atmosphere could then be stripped away by solar winds. So I'm not sure what would happen to our gas giant, if it would blow away or if it would still be strong enough to hold on to its gas. I think it would still be strong enough, but it might slowly wear away over time. Plus, our sun's a bit weaker now because it's made out of shitty shit instead of, good old pure hydrogen and helium. So that's kind of neither here nor there. But I'll end what I'm doing with one last fun fact. So around big planets like, say, Saturn, the rings that form are actually a result of stray, what they call planetesimals, which are those starting building blocks of planets, like the first clumps. So they result from those stray planetesimals being torn apart by gravity when they venture too close to the planet. So, in addition to being a gas giant, there's a very good chance that Earth is going to have some pretty kick-ass rings, because there's going to be a lot more of these planetesimals floating around. And so even with the speed of our formation, I think we're going to have a gas giant with giant rings, and if we're lucky, those rings will be made out of onions, and we'll have big ol' onion rings.
Awesome.
Yep, that was it. I spent 3 days of research to make an onion rings joke.
That pretty much
Are onion
sums
rings,
up this.
Are onion rings Thanksgiving? I don't know if
They
There's
should
onions
be.
and shit.
I guess they are.
There's plenty
like
of onions.
casseroles. Yeah. Green bean casserole has onions on them.
Yeah, and who knows? Maybe Earth is in this Goldilocks zone where like everything disintegrates but onions. I don't know. I'm just saying it could happen.
No one can disprove us.
All right, welcome back, everybody. It is time for our Would You Rather question. Chris, you said you have one today.
Yes, I have one today. Marcus, would you rather your fingernails grow 100 times as fast or have no fingernails at all?
Ooh.
So I did a little bit of math just based on like how often I cut my fingernails, and 100 times as fast would end up being you have to cut your fingernails every 3 hours.
Okay, 3 hours. And that's like just like slightly long enough where I'm like, oh, I should probably cut them.
Yeah, you could probably go further than that if you want to just deal with long nails, but yeah.
Jesus.
All right, clarifying question. If you don't have fingernails, I know the reason we have fingernails is to, like, our fingertips are more sensitive than other parts in our skin, and the fingernails protect all the, like, nerve endings there. we have less sensitive fingertips.
Is that why fingernails are there? They're not just vestigial claws?
Yeah, I didn't realize
I think
that.
that's part of it. I'm pretty sure it's part of it. Maybe I'm wrong.
I would
but...
say, like, the back of your finger is like the front of your finger.
Interesting.
I don't know if that answers your question.
I don't know either. Well, first, I guess I now doubt my fun fact. Quick, let me Google why we have fingernails. Hold on.
All right, so getting into the habit of clipping your fingernails is reasonable.
Yeah, but 3 hours is very often.
It's very often, but I mean, like, say you can go say you push to 6. Once you're at 6, it's fine.
Yeah, I guess so.
Like you would do it in the morning, like part of your morning routine. You do it when you get back from work, and you do it before you go to bed. So it'd be 3 times a day, which would be 8 hours apart. And you would have instances of pretty long fingernails, like really not when you need them, like the end of the workday. You would have them when you wake up, and you would have them like just as you're going, right before you do your night routine.
Yeah, I guess you could just do it like when you brush your teeth. Right?
Yeah. Like I said, you can get into the habit.
The thing is, like, cutting your fingernails, I feel it's like a bigger chore than just like brushing your teeth for some reason. I don't know why. It's actually not that hard.
Because you don't have to do it as often. You're out of the habit.
It turns out my finger sensitivity thing is bullshit, so ignore that. Don't know where I got that one.
Ben, you should take breaks from the podcast more often to come back and tell us you're wrong.
Apparently.
I like having fingernails, though.
I do like having fingernails.
Yeah, they're useful.
I'm trying to imagine what it'd be like without my fingernails. It's very hard to imagine.
Oh, you couldn't scratch yourself.
And there are plenty of times where I like cut my fingernails too short, and like the day after I need my fingernails for something.
Yeah.
They're so handy.
Hey.
Oh, hey, I didn't mean to do that. Oh, you also don't want to be the person with no fingernails, because that's weird as fuck.
Right.
Like,
Yeah,
not that I
it's
spend a
kinda
lot of
weird.
time looking at people's hands, but if someone didn't have fingernails,
You would notice it heavily.
yeah, you like notice it immediately.
I don't know if I would notice it right away.
No, I
I'd have
think
to
you would
be looking at their
definitely
hands.
super would.
I don't know. Fingernails are like kind of translucent. Like they kind of blend in with the rest of your with your skin color.
Yeah, they do, but at the same time, I think it's one of those things that your brain is like taught to be like, that's wrong. That right there is incorrect. That's not supposed to be that way. There's something wrong with that person.
Yeah.
Is there anything useful you can do with fingernail clippings?
Oh
Oh god, that's gonna be the worst Google search.
no, why are you doing this to yourself?
Clippings.
Make a macaroni painting, but with fingernails.
Oh god.
Use nail clippings to make a pot scrubber? No!
Oh.
No.
Run out of steel wool but still have pots and pans encrusted with impossibly hard food bits? No matter, create your own pot scrubber by collecting your fingernail clips and emptying them into the foot of some discarded pantyhose.
Wait, okay. I like the idea that they phrase this as, did you run out of steel wool? Because that implies that you would run out of steel wool and spontaneously be able to do this, which means that you just have like a pile of nail clippings somewhere.
Been collecting them.
Yeah, just for this exact moment.
I mean, you are going to have a lot of extra fingernail clippings in this situation. Like, way more. 100 times more to be exact.
Okay, number one, so I'll read this post of the ways to use fingernail clippings. Number one, put them in your compost pile. That's not reusing them, that's throwing them out.
What are fingernails made of?
Keratin, mostly.
Yeah.
So, like, your excess calcium buildups and whatnot. It's like your body minerals. And they extrude out your fingers, which is weird saying it like that. What the fuck,
That
body?
is weird.
How do you get the rocks in my body to my fingers? The human body is an amazing gift.
They can transform rocks into nails.
All right, I feel like we should vote.
Okay.
I don't know what my vote is. God damn it. You said 3 hours?
Yeah, it was 3 hours. If for like a normal length that you would cut it right now.
Right, yeah.
But you could make it go longer if you want. Because having long nails is annoying too.
Yeah.
Having nails that are too long.
Like, the big thing I'm seeing is, like, if I, say I go, into the city for a day or something, I actually, like, carry around nail clippers and, like, sneak off every 3 hours
Yeah.
to clip my nails. Like, that's...
You could very easily miss the 3 hour thing.
Yeah.
I mean, is it worse than, like if you have, like, IBS or something where you have to make a trip to the bathroom every once in a while?
Right. It's not like it's an emergency. It's not like it's, like, at 3
Yeah, it's not an
hours you
emergency.
immediately have to do it.
You can deal with it.
Yeah.
Yeah.
But like breaking your nails sucks.
Yeah.
Yeah. It would heal quickly.
True.
That's true.
I don't know. Just every time I look at it, I'm like, man, having no fingernails would be a horrible fate. And I'm like, every time we talk about, the inconveniences of them growing fast, I'm like, I could deal with
Yeah,
it.
I think I'm going to go with fast growing, too. Yeah. Yeah. I need fingernails.
I think I agree, actually.
Yeah, fast growing. Ugh, God, I'm like skeeved out right
Yeah, I'm
now.
not happy about this.
Ugh.
You're welcome.
No, fuck off. You suck.
Why are Would You Rathers body horror so frequently?
I think that's just what most would you rather, because like, I don't know. Maybe we're just sick people.
Maybe, yeah.
You should do more superpower ones.
Yeah, we should do more positive ones. More like, oh, I'd love to do that.
Right.
Instead of like having to imagine myself in two untenable situations and making myself pick one.
That's a good plan. We'll never do it.
But today is our Thanksgiving episode. So that means we have to be thankful for things, guys.
Oh, no.
And I just want my listeners to know that my thankfulness for you guys listening is like the beautiful Thanksgiving food nebula that expands out through space, glowing brightly at its core as it slowly compresses into a hardened nugget of pure thankfulness, which will then shine brightly and illuminate all the wonderful stuffing planets that are my ears and eyes and all the ways that I acknowledge that you guys support us in our creative endeavors. Chris, do you have a metaphor?
I was going to do something Thanksgiving related, but I don't know. Now I guess I'll come up with something else.
I have one.
Okay, you go first.
My thankfulness is like a fingernail, ever growing, continuously, disgustingly, to the point where it's actually a little annoying sometimes, and I have to, like, figure out ways to deal with it. But at the same time, I am glad that it is there, because my life would be so much worse without it.
You can turn that thankfulness into the podcast, which is effectively back scratching for our listeners' ears.
Yes, exactly.
Okay, my thankfulness is a glass of water.
Are you just looking at things on your desk again?
Yes, I've resorted to that again.
Oh my god.
It's a glass of water that is half full because I've drunk some of it. I guess the water that I already drank is motivation to start the podcast. And then my thirst is my motivation to continue the podcast.
My dying need to be validated at all times.
Yeah. And then when I actually drink more, when I finish the glass and my thirst is quenched, that's the thankfulness going into my body and replenishing my fluids. And the cup that's holding the water is, I guess, you guys.
They're like 5 things now.
Wait, I don't know if the cup is listeners or if it's you, like the co-hosts. I guess it is...
I don't know, who keeps your shit together, Chris?
Who holds the thankfulness? I guess I hold the thankfulness. I'm the cup.
I was the cup the whole time.
I'm the cup.
There's a twist. There we go. That's mine.
All right, so for anyone wondering what the hell in the God's name we're doing right now, so this is a brief sample of our thankfulness metaphors. And we'll actually do these at the end of all our behind-the-scenes episodes. It's kind of against all 3 of our wills to do these things, so I'm not sure how we started. But if you go on to our Patreon at www.patreon.com/absurdhypotheticals, and for just $1 a month, we only have one tier, and it's only $1, you get access to all our behind-the-scenes episodes that we do, where we review the last month's questions in kind of in hindsight, talk about what we really thought about each other's answers, where we got things wrong, a little bit behind the making of the show, lots of cool stuff. It's a cool, chill hangout if you want to get a little bit more of us in your ears. And yeah, we do these thankfulness metaphors each and every time, completely new, off the cuff.
Yeah, we do it. We purposely don't prepare for them.
And it's just a fun way to... It's not really giving back. I don't know if it's a positive experience for our listeners watching us butcher the English language and literature like that, but it's what we do.
Well, you always do it very well. Like, you always go first and you always, like, nail it. And then Ben and I are just terrible at it.
Yep.
Which makes it, I guess, way more fun for me.
Yeah.
So yeah, it's all about me doing these things. And this next week's question is kind of also all about me, because it's board game themed and I design board games. So join us next week where our question is, what if life was like a board game?